Hello, today we are covering 9.4 composition of translations. You guys will be able to draw compositions of translations. We have composition of transformations and glide reflection. So glide reflection. When a transformation is applied to a figure and then another transformation is applied to its image, the result is called a composition of transformations. A glide reflection is one type of composition of transformations. So this glide reflection is like walking. A glide reflection is the composition of a translation followed by a reflection in a line parallel to the translation vector. So for example, the glide reflection shown in the composition of a translation along vector W here, followed by a reflection in L, is what makes this glide reflection. So you start here, you have a transformation, and then you reflect, and then you transform, and you reflect over L. Okay, so we're going to do some of these. So quadrilateral BGTS is already graphed for us. So we are going to then graph BGTS and its image after a translation along vector 5, 0, and a reflection in the x-axis. So what I'm going to do, at least for this first one, is go ahead and write out my work. So I have my original, but I'm going to go ahead and just add in my vector to each of my x and y coordinates. So g is negative 1 plus 5, 3 plus 0, t is negative 1 plus 5, 1 plus 0, t prime I should say, and s prime is negative 4 plus 5, 2 plus 0, and then I'll go ahead and finish these out. B prime is 2, 4, G prime is 4, 3, T prime is 4, 1, S prime is 1, 2. So these are not my final products. I have 2, 4 is B prime. G prime is 4, 3. T prime, should have a prime there, sorry about that, is 4, 1. And then S prime is 1, 2. Now, that's just the translation. I now need to reflect over my x-axis. Now, reflections weren't too hard. You just counted to your x-axis and then counted that same amount on the other side. So I'm going to do that. Make sure it is the x-axis. It's the one labeled x that we are reflecting over right here. So G is 3 away, so I'll count 3 on the other side. And I'm going to mark these with double prime. So our final composition of transformations is this guy right here. I have marked them all double prime to distinguish, although you could get rid of this middle step if you wanted to, and then get rid of one of your primes for this image, like so. Okay? So let's try another one. We can do some of these things without showing out all of this work, as long as you know the steps, although showing out the work isn't a bad idea. So we have quadrilateral RSTU. We have to graph it this time. So 1, negative 1, 4, negative 2, 3, oops, not a prime, 3, negative 4, and 1, negative 3. Then we are going to graph that in its image after a translation along this vector and reflection in the x-axis once again. So what I'm going to do actually is I'm just going to use our counting method of our vector. From point R, I'm going to go left, left 4 and up 1. So here is R prime. Then I'm going to do the same thing with S. This is S prime. Then I'll do the same thing with T. T prime. And U. U prime. Okay? Now, that shape will not be needed in our last answer, but to get to our actual answer with our reflection in the x-axis, I like to do this. So we're reflecting across this axis. Notice R prime is on that, so R double prime is actually the same thing. S prime will become S double prime here. T prime is 3 away from the line of reflection. Maybe I should draw that in, huh? There's our line of reflection. T prime is 2, 3 away from the line of reflection, so we need to go 3 on the other side for T double prime. And then U is 2 away, so we can go 2 on the other side for U double prime. Okay, so this is our actual answer here. That is our final image. So we can get rid of our middle step as well as our double primes. I just like to use those to distinguish. And there is my answer, my composition of transformations. Okay, we have 2 more. TUV has these vertices already drawn for us. We're going to graph TUV in its image after a translation along -1, 5, and a rotation around 180 degrees, okay? So, we go over -1, up 5. That is T prime for now. You go over -1, up 5 from U. This is U prime. And then V, do the same thing. This is V prime. Okay, that's not the answer though, it's a composition of transformations. So we have to do our rotation now about the origin. So to rotate about the origin, it would probably be easiest to go ahead and write out the coordinates of T prime, U prime, and V prime. So T is 1, +4. U prime is 4, +3. And V is 1, 2, 2, 1, my bad. 2, 1, over 2, up 1. All right, now, for a rotation, X and Y stay the same when we're doing a 180 rotation. So we end up getting that they stayed in their same spots, but they switch signs, not with each other, but to the opposite version. So if they were positive, they become negative. If they were negative, they become positive. And we can graph this rotation now. -1, -4. -4, -3. -2, -1. And that is our composition of transformations. You can get rid of this middle one if you prefer. You could highlight or circle the actual answer. So after a translation along our vector -1, 5, and then a rotation 180 degrees from the new one, we get to our answer. Okay? Okay, so we have triangle JKL. We're going to do this without having a coordinate plane. Totally fine. After a translation along the vector 3, 1 and a rotation 180 degrees about the origin, what is the new coordinate of L double prime? So we don't even super have to care about the other ones. We can just worry about L, starting out at 3, 0, goes to L prime, where we say, well, 3 plus 3, and 0 plus 1 is equal to L prime of 6, 1. And then for L double prime, when you do 180 degree rotation, like we just talked about earlier, they become the negative or opposite versions of themselves. So our coordinate of L double prime after our translation and our rotation is -6, -1. And that's it.